Hi, I'm Hw6q1. Let's do the first question of homework 6. We are given an joint density function of x and y here. And the first part, we need to find a, so that the density function is a valid joint density function. To make sure the function is a valid joint density function, we just integral on the range from -1 to 1 dx dy, let it equals 1. It equals to 4 over a, and make it equals to 1. Now we get our a equals 4. The second part, x, y, and correlates. We need to calculate the mean of xy first. It equals to an integral from -1 to 1, then times xy times joint density function we got above, which is 1 plus x times y, then divided by 4. It will be 1 divided by 9. Then we need to calculate the mean of x, ax, similar to mean of xy. Is we need to integral from -1 to 1, then let x times joint density function dx dy. The result is 0. And now we can find that the mean of x times y is not equal to the mean of x. So x, y are not and correlated and are not independent. Now let's do this part. We need to find the joint density function of x squared and y squared. First, we need to let z equal to x squared and w equal to y squared. Now we get j equal to x squared 2 times x and 2 times y, 0, 0, which equals to 4 times x times y. And z equals to x squared, w equals to y squared. The equation, this equation has 4 rules. When z is larger than or equal to 0 and less than or equal to 1, and same as W. We got our J I equals to 4 times Z W. And we can get the joint density function of the W, which is joint density function xy. X is z, and y is w, and divided by j1, mod j1. Same as first part, we need to calculate, sorry, it's not equal, it's plus. You need to calculate the last 3 parts. The result will be 1 divided by 4 times root zw, then times 1 first, 1 plus root z times w, then plus 1 minus z times w, then plus 1 minus z times w, then plus 1 minus z times w. The result is 4 times use the w. And this on the range of z is less than or equal to 0, is larger than and or equal to 0, and less than or equal to 1, and this is W's range. Otherwise, the result will be 0. So that we now we have the joint density function of x squared and y squared, which is this range, and 0 otherwise. The last part, we need to prove or disprove that x squared and y squared are independent. Let's do the last part. To prove or disprove that whether x squared and y squared are independent or not, we need to calculate a density function of z x squared and the density function of y squared. We already calculate the joint density function of x squared and y squared. We can easily get our density function of z and w. The joint density function equals to the density function of z times the density function of w. so that x squared and y squared are independent. Okay.